Hello students, Ms. Slyman here with our next set of notes on how to use our GDC. So when we're looking to use our GDC, the other way we can solve equations is to graph just one equation and look for x-intercepts. Well, if I think about a graph, then on any sort of graph, here's my old graph, maybe, yeah. So if I think about an x-intercept, here's an x-intercept here, and here's an x-intercept over here. So for any x-intercept, the y value is equal to 0. So to use the x-intercept method, first we have to subtract or add. So add or subtract one side of the equation to make it equal to 0. So that's our first step. Then the next step is going to be that we graph or put the non-zero side, enter non-zero side into y1, and then we use second trace and 0 this time to find the x-intercept. And again, we made this equal to 0 because y equals 0 at x-intercepts. So use trace and second trace and 0. And then what we're going to do is answer the questions again. So looking at my equation up here, it's the same one from before. If I'm going to make this equation, make this right-hand side equal to 0, that means I'm going to have to subtract this whole side to the other side and add this side. So let's see what that looks like. So I'm going to come into my calculator and I'm going to clear out this second one, but up top I've still got that same left-hand side. So I still have this left-hand side, and now I'm going to subtract and add the right-hand side. I want to make the right-hand side equal to 0. So if I subtract the whole parentheses, 3 plus 0.2x, so I'm going to subtract the parentheses, 3 plus 0.2x, close the parentheses, and now I have to add 4.17 to make 0, so I'm going to add 4.17. Now this time if I graph, I'm only going to have one line. And there's my one line, and here's where it intersects the x-axis. That looks like it's just a little bit bigger than 2, and that's good because I should have the same solution. So now let's go ahead and do second trace. This time I'm looking for the 0, so that's number 2. The left bound, it's asking me, what is a number on the left side of your axis of your intercept? So a number that's clearly on the left side is x equals 1. A number that's clearly on the right side is x equals 3. My guess is that it's just a little bit bigger than 2, so I'm going to say 2.1 again as my guess. And I get the exact same value as before, and again, we'd give our answer to 3 significant figures. So over here, I have now used the 0 function, or the x-intercept method. And that's that method.